answers, by the way, to the grouping. This is stuff that is predicated off of your geometry coming in, or sorry, knowledge of geometry coming in, and looking at where you all come from. There's a lot of different ability levels as we progress through, and some of us are going to have to work a little bit harder than others, and that's fine. Take a look at what we have for the first one here. The toughest ones were this. Now, am I expecting you to literally do this out on graph paper? No. But we should be familiar with how to get an x-intercept and a y-intercept. To figure out how to get an x-intercept, you set y equal to 0 and solve. To figure out how to get a y-intercept, you set x equal to 0 and solve. The other questions that came up most frequently were about these last two, about the calendar questions. On those, if you get stuck, give me a graph of it. Construct a Cartesian plane, plot the points indicated. Some of them you may need a little bit of a refresher because we had 5 kids that came in this morning that said, hey, I'm stuck on this one question, and don't misconstrue. I applaud you for having the effort of coming in. We were discussing, well, how do you get an altitude? And I go through and say, well, I know how to construct an altitude, but my altitude can give me the slope, but it's got to go through that point C, so I've got to go through and make it have that slope through point C. And then the other end of it was, what was the second thing it asked for? It asked for altitude. What was the other one? Is it a median? Median. So then I go through and say, yeah, if I'm stuck on what a median is, the one thing that's terrific is you can take out your computers and just Google what is a median. And then you can go through and find that and use it to help yourself and inform your choices going forward. Now, we have one question. Now, here's the other end of it. Very seldom do we go over math questions in class. One of the reasons is you all are very good. Well, I may be in the reasons class, maybe not you all. But they ask so many questions that we never finish anything. Like I would sit there, there's some colleagues sometimes that walk around and go, well, the first 20 minutes is homework questions. Why don't you just do the homework, like as a group? You should be giving more than 10 or 15 or 20 minutes of homework anyways. But if you're going through and doing that much, that's a lot of time. So if you have questions, we'll be more than happy to answer. But you got to make sure that you come in at another time. If we have time, though, we'll go over 1 or 2 today if you need it. Do we have questions on any of these? Yeah.
Number 2.
The problem is, and I'll try to send this out for you because I don't have the graph of it done, and you need to visually see it. So that's the only reason why. I'll try to message it out to you all through Remind at some point today as to how you get the answer for the calendar questions. Those are the answers for it. Is there any ones on 1 through, was it 41 or something like that? All right, so make sure, oh, did you have one?
Yeah.
Okay, which one? 10 overall?
Yeah.
Can I just see, does everybody have the packet itself so I can hear?
Yeah.
For question 10, it gave you this relationship. It says, School Glee Club needs a total of $4,500 for a trip to Nebraska to make the money. They're selling the caps for that much and that much. Graph the equation where x is the intercept. So, in order to graph it, how many points do you need to get in order to graph out the equation of a line? 2. That's it. So I found the x-intercept and the y-intercept. How do you find the x-intercept? Well, you set the y equal to 0 and solve. Same thing. So when I do that, I get these 2 values. So I know now that my graph is going to have to go through this point here and this point here, and I literally just constructed a graph and made that happen. Scaled it appropriately. Now the second part is explain the meaning of the x and the y-intercept. Well, when the x is 0, what's the y value in terms of a number? 360. What does that number mean? Who can tell me? See, this is the concerning part. Put yourself in the question. You should be able to answer this question, hopefully a little bit easy. Yeah.
He sells 360 sweatshirts to reach 4,000.
And no, 0 baseball caps. Now go the other way. What does the y-intercept mean? You'd have to sell 1,000, what was it, baseball caps? 1,000 hats and 0 sweatshirts, or some combination of them, any point on the line in the first quadrant. By the way, another thing, why can't we dip into the second quadrant or the third quadrant? Or sorry, second quadrant or fourth quadrant in order to have this? Yeah, you can't be just giving people money for hats and sweatshirts that they didn't buy. So make sure, please, that your name is at the top. Hand those up and over. And have out your note packets open to where we left off the other day. That's fine. There's a stapler on my desk. You make sure to put the paper in. Be careful, it's profoundly high powered. It's electric. Make sure you cover your eyes when you're doing it. It's very, very strong. You got to really push it in there and it'll click over. Push it straight ahead. Instead of turning the paper. All right, so we left off on topic 2. What page in the notes is this on? 7. All right, so we left off on page 7 in the notes. What you all need to go through and do is this. We're going to start off with talking about what a relation is. And a relation is just a set of ordered pairs. Again, we left off on page 7. A relation is just a set of ordered pairs. It is not a function. A relation is not guaranteed to be a function. It's just a mapping of input and output values. Looking at what's here, it's represented by any of these. Now we're going to talk and extend on what's here and then work towards our answer. Looking at this to start, this relation is 3 points. Notice the notation. If you're giving out a relation or a grouping of 3 points, you don't use more parentheses, you use those fancy brackets. Let's do this out. Hopefully maybe some of us remember. Who remembers what the domain is going to be? We've got 1. What do I say? Domain is the x values. So in this case, our x values, we use the fancy brackets. 1, oh, and I hate this. This is a personal pet peeve. List them out from least to greatest. My domain is the x values that I use, so this would be -9, 1, and 3. How about for the range? The range is the output or y values. Hands up, please, if you can tell me what the range of this set would be. Here's the 1 person, 2. What do you want to say? So I go through, give out the brackets. The smallest one's a 0, then a 3, then a 5. Now, the next one, some of you, in order to give out the domain and the range, some of you instinctively run to the calculator, and we should be beyond that, especially as honor students. Looking at what's there, hands up please if you can tell me what that graph, what shape that graph is going to have. We got 1 person that can tell me what this is going to be the graph of. Seriously? Oh my God. 2 people. 3. This is not supposed to be a tough question. What do you want to say? Yeah, it's a line. We're supposed to be able to recognize lines. The slope of this is going to be, so I go through and say, all right, so this is what the graph looks like. I can get a pretty good estimate. This graph has a y-intercept of -5, a slope of 7, so maybe it looks something like that. Now, the domain is the input values that give you an output. So looking at this, as I go out to the left, I'm always going to be plotting points. And as I go out to the right, I'm always going to be plotting points. Looking at what's there, there's 2 ways that I could give out the domain. There's 2 ways that I could give out the domain. The first way is to go through and say, well, we'd have to ask ourselves what values work. And when all of them do, you could either list out this here, this fancy, I guess we'll call it a double R. That means all real numbers, but that's not the one we want you to use to get yourself ready to be successful beyond this class. You all, the first grouping said, do you remember hearing or using interval notation before? Yes or no? Yes? No? There's lower bound, comma, upper bound. There's brackets if it includes the value, parentheses if it approaches it and doesn't include it. So looking at this, to state every number, I go for my lower bound, so this graph goes forever out to the left. So I'd say negative infinity is my lower bound. I go out to the right forever, so I'd say positive infinity is my upper bound. And when I list it out, I put parentheses on both. It continues out forever, but since it doesn't ever end, it approaches infinity from the left and from the right. That's why infinities always get parentheses. They never get brackets. Looking at the range, we're going to ask ourselves, how low does this graph go? Well, this is a line, and it keeps dropping forever. So it goes all the way down, and the range on the y goes all the way up. That means my range would be all real numbers as well. The other way to list that is in terms of a lower bound, comma, upper bound. And so this would be negative infinity to positive infinity. Looking at example 3, that's the graph of a parabola. Looking at that, what would our domain on this be? Where's the T? What would your domain be? Okay. All real numbers. What's that going to look like in terms of an interval? Perfect. And by the way, I always ask that you put the signs on the infinity. If you ever have Math Excel homework, you don't put the sign on a positive infinity. What about for the range? Kirsten, what do you say? Now, does it keep going down forever? What's the lowest it goes to? 0. So it goes... Does it include the 0? So will we put a bracket or parentheses after? Perfect. Perfect. Looking at this next one, this is a relation as well. This is not a function. Does anybody know why this would not be a function? It's a mapping of an input onto an output. Yeah. There you go. A relation is a function if every input has at most one output. So looking at this, Jan has one output. The problem here, January has one output, February has 2, and then March only has 1. So the reason that this isn't a function is because of February having 2 outputs. If I got rid of this line here from February to Amy or February to Sue, that would be, then it would be a function. The other thing we have to ask, well, the other topic that we need to know is whether or not something is onto. So we need to know whether something is a function. And then if it is a function, we can ask ourselves, is it onto? And an onto function means that every available output value is used. So I look at this line right here. This graph goes down forever and up forever. Are there any y values that I would ever not get to? No. It's going to drop down forever and rise forever. So this is a function, and it's onto. this is a function, and this is not onto. Can anybody tell me why 3 would not be an onto function where 2 would be? Why would 3 not be an onto function while 2 would be? Got one person? What do you want to say?
Because we only gets all positive numbers,
Yeah, so tell me a value that exists as a possible output value that you're not getting from that graph. -2, -5. Any negative number exists, but the graph is never going to hit it. Okay? Now, this one over here, some people in the other class are going, well, this one is not onto as well. And there's a problem with that. This would not be onto because Josh wasn't used. And I guess using their logic, they're kind of right. There's one problem. Is 4 a function? No. So we don't even get to that piece about it being onto. Let's go over and look at the next grouping. And we said this before. Your domain is the input values that you use that give you an output, because you could plug, 50 into a function. Doesn't mean it's going to give you an output. The range is all the y values that we use. We already did that. We stated what the domain and range were for each of those. We didn't say what it was, sorry, for 4. But the domain would be all of the names that are used, and the range would be all of the y values used. What is a candidate for the range but not used in 4? Take a look at that example above, example 4. Which one is a candidate for the range but not used?
Josh.
Yeah, Josh. That one's never used. Hopefully this piece, though, is all review for you. All right, so now we're going to give these out, and you're going to have to go through. Go through right now and figure out the domain and range of those two. 1 is going to be easier. 2 is going to be, I guess the domain on 2 is a little bit tricky. And so is the range. But you should be able to at least give a guess as to what you think it is. A should be hopefully a little bit easy for us. The domain is the inputs that give you an output. The range is those outputs that you get. So, looking at what you've got for A, where's Connor out? Connor, what would you say that your domain is for A?
-4, 4.
And am I putting brackets or parentheses there?
Brackets.
On both? Okay. Let's take a look now at what the range is. And Philip, what do you say that that would be?
in brackets, -2, 2.
Perfect. Now this next one is hard. And some of you are going to see something there and you get a little bit preoccupied with it. There's Amanda P. Amanda, what would you say your domain is for B? Close. Who can tell me the one jump, because it does go out forever to the left. What value is not included in our domain? We've got 3 of us, 4. Nope. 0. Remember, and that was the part that I label it and you guys get. This -1 and 1 is in reference to what? The range, yeah. So when we do this out, it's everything but 0. So think about it as you're running along the line in a lower bound and an upper bound. So this is everything here until I hit 0. Then I need to jump over the 0 and continue out to positive infinity. Now the range is a little bit interesting to see how we could go through and give it.
It would be parentheses -1 to 1.
Close. Now, that's closer. If I said that the range was -1 to 1, what is this saying that is not true? It's close. It's very close, especially if we're not seeing it before. That's very good. It's including this space here. Does the graph go through any of these intermediate or middle points? So really, there's only two values that are in the range. It's just -1 and 1. So there's more than one way that we can do it. So let's say we go through and say, if you gave it as two separate sets, I guess you could look at it as this, -1 to 1. Or you could say that the range and give it out as values, -1, 1. Not parentheses, because remember parentheses would make it a point, or an open interval, which it is not. But that second one is very tough. Seeing what those values are is key, and we did that. Questions on that? Now, when we went through and did this, a function is a relation, and you guys already answered this, in which every element of the domain corresponds to, at most, one element of the range. Which of the following is a function? So, is A going to be a function? Corey asked, what do you say?
No,
Why not?
because red has everywhere it has two outputs.
There you go. How about for B? Sam, is that a function? Is it an onto function? Why not? There you go. Now, we'll tell you this. We're tag teaming this course with some people in Pittsburgh and Fayetteville, Manly, and Syracuse. So, you can tell she made up this slide because maybe we'll make it Trader students. But in any case, what about Trader students getting mapped onto their guidance counselor? Would that be a function? Think about what the input is and the output is. Yes. Because do you have more than one guidance counselor? No. What about going the other way? What about the guidance counselors getting mapped onto their students? Is that a function? No. Why not? Who can tell me? Hands up, please, and you can tell me why that wouldn't be a function. What do you want to say? Yeah, hopefully they do. Taking a look at question E, is that going to be a function? John, what do you say? There you go. Every input has only one output. Take a look at A. Megan B, is A going to be a function? Yep. Does anybody remember the graph test to see whether or not something's a function? Who remembers what you have to do? Yeah, it's called the vertical line test. So if you draw a straight line, it can touch the graph at most once. How about for C? It's called the vertical line test. We write it out as VLT. How about for B? Sabrina, is that going to be a function? No, it fails the vertical line test. That's the graphic representation of it. Because this input, let's say it's -1, has an output here and here. Now, a function can be stated as a rule or an equation. All of these mean the exact same thing. I take some input value, I plug it into the function, and I get out an output value. If it spits out an output, it's in the input, and those output values that we would be collecting at the end, those are called the range. All of these mean the exact same thing. We go through and name functions, so if we're ever talking about more than one, it's a heck of a lot easier to go through and see. All of those mean the exact same thing. However, on the reach, they're only going to ask you, this is called function notation. It could be f of x, it could be g of x, it could be h of x, it could be a of x, it could be b of x, it could be c of x, it doesn't matter. It's telling you the function, and it's not always going to have to be an x, right? It could be f of, let's say, a star is equal to the star. Oh, that's I don't even know how to draw stars. Would be equal to the star cubed plus 3. That's all it's telling you to do. The f is the name, the x is what your input is. It could be a picture of an apple, doesn't matter. It's telling you to take the input, cube it, and add 3. This is telling you the function with x inserted into this. This is telling you x getting inserted into the function f, which is defined by that rule. They all mean the same thing. The two highlighted ones are the ones you got to know, though, for sure. Now, we're going to talk about what our inputs are. And again, this I found fascinating from the other class. I think did we talk about Cartesian plane the other day? And how we didn't know what that was? We're going to make sure that we're sticklers for our language, so you go on. It's almost doing a disservice to you to be in an honors class and not know these things. This right here, the G minus 3, this is called your radicand. It's the expression or the argument that's getting that is housed under the radical. That line is called a radical. Underneath it is a radicand. You could say radical of x minus 3, or sorry, actually it would be the radical of the quantity x minus 3, or the square root of the quantity x minus 3. So the first one up, here's our 3 or 4 for this. First one up, I'm going to evaluate out g of 3. So that means I'm going to go to my g function and replace the input with the 3. So this is the square root of my input minus 3, and in this case the input itself is 3. So I show out my substitution, I simplify the radicand, and let's see, does the square root of 0 exist? Can you take the square root of 0? You would think we were talking about politics. It's so split 50-50 when you ask this question. Can you take the square root of 0? Got no's? Hands up if you're a no. Hands up if I love this too. It's like this is like a glacier rising up. What about who says yes? Okay, see? Or actually you're about 50. You said yes. Why would you say yes? There you go. I just found a counterexample as to why. If my belief was that it didn't exist, I found a counterexample as to why. If you get stuck, you can go to the calculator and type it in. Next one up, I'm going to go through and evaluate out g of m squared plus 3. Now this one, again, is very difficult. I'm going to place this in and say, all right, here's my square root. So it's the square root of the input minus 3, except in that input spot, I'm now going to replace that input with m squared plus 3. So that's what I'm left with. Now look at the radicand. That simplifies down. Mickey, what would that radicand, as it is now, what's one simplification that you could do on that? So I'm left with the square root of m squared. And some of you are going to be getting this wrong right now. This comes up in calculus all the time. When you take the square root of something squared, it doesn't equal the value proper. It equals the absolute value of that, because you're taking the square root of something that was squared already. So if there was a negative and you square it, you're going to lose it. My input could be, let's say I had plugged in a 7. A 7 and a negative 7 would give you the same thing, because when you square the input, what happens to the negative sign? It goes away. So we've got to account for the fact that that could exist. Last one up, how about if we did g of 0? Now, we would get the square root of 0 minus 3, which is going to be the square root of negative 3. At this point, we're going to label this with d and e. Now, who is an inspector that can figure out what they think d and e stands for? We got 1, 2. In the last class, they looked at me. This was like a 12-minute thing, and they go at the end. What does d and e mean? I presupposing too much, and I'm sorry. Who can tell me what they think d and e is? 2 people? 3?
Does not exist.
Does not exist. Why does that not exist? As it currently stands, you all have not been shown the math that will allow you to take the square root of a negative radicand. 0 isn't in the domain. It doesn't give us an output, and we're talking about making our domain the set of real numbers, not imaginary numbers. Now, looking at what we've got for that last one, I'm going to give us this. We're going to actually, we may come back to this. I want to make sure that we get enough done. We can table this D for just a second. Again, we may come back to it if we have enough time at the end. A function malfunctions when you take the square root of a negative number or you have an undefined expression, which is division by 0. Did I show you all this yesterday? That it's okay to have it in the numerator and not okay to have it in the denominator? Your 0 shows up in the numerator. What's the value of the fraction going to be? Terrific. Terrific. You can't get an answer, though, if it's in the denominator. Now, we're going to determine what the equations of these graphs, we're going to determine what the domain of them is and the range. We're going to do a little bit of it before we go right over to the graphing calculator. Here's the first one up, the square root of x plus 2. And when you say the square root of x plus 2, that's what it is. If you mean the square root of the quantity x plus 2, you have to state that. This is going to be a graph of a parent function, which is the square root. And then we're going to shift it up 2. That's what that plus 2 on the outside of the radicand means. Now, a square root function, well, let's do this. Maybe we can do it by a table. Let's make a table in our head. I'm going to plug in an x value of 0. What's the y value for this going to be? Hands up, please, if you can tell me. You don't need to go to a calculator to figure that out. Plug a 0 into the y, plug in 0 for the x. What is your y value going to be? We'll wait for 8 of you. We've got 3, 4, 5. What would our output be if I plug in a 0 for the x? 2. So we know the point 0, 2 is on there. Can we graph anything at -1? Try plugging in a -1. What's the square root of -1 plus 2 going to give you? Doesn't exist. Can you tell us why? Because what's a negative? Perfect. See, now we sound like we're going to be ready for calc. The radicand is negative. We don't have a way to simplify it down. So there's nothing over here. Who can give me another x value that you can tell me the y value for? You're going to probably want to pick easy inputs that would lend itself easily, in this case, to an output. We've got 1, 2 of you. 4. So when you plug in a 4, you got the square root of 4, which is? And then? Which is? All right, so we know 4 4s there. 1, 2, 3, 4. 1, 2, 3, 4. So that puts me right about there. Who can give me another input value that I can fit on my graph right now? You got one person? Think about the number that you'd be taking the square root of. What's a number that we could hopefully handle kind of, I don't say easy, but manage in this situation, especially without a calculator? 3 of you? 4? No, because we don't know what the square root of 2 is exactly. 1, because what's the square root of 1? And then plus 2 gives me? So I graph at point 1, 3. Now the square root function looks something like that. We're going to state what the domain of this is and the range. And we're going to use it in interval notation. This graph starts at 0 and continues out forever. Let's see. Where's Grace P? Grace, what would you go through and get for your domain? What's the lowest?
0 to top.
Good. We're going to put parentheses at 0. What gets put at the 0? Perfect. Close bracket. How about for the range? Where's Ben B? Ben, what would you go through and get for the range? What's the lowest value that it goes to? No, because this isn't going to drop forever. You can tell me how low this graph goes. 2 of us? 3? 4? That's terrific. That's great. We're going to put a bracket or parentheses here. What do we think? That's great. Good job. Next one up. So that's our domain and range. Do we need a calculator to graph that one? Our y-intercept is going to be -4, so I go to -1, 2, 3, 4. Go here. My graph is going to have a slope of 3. It's going to look something like that. What do we think, Sean K., what do you think that the range on this, or sorry, domain is going to be? Terrific. All of them work. Where's Marissa D? Marissa, what is the range on this going to be? Great. Questions on that? Now, these are the ones where we're going to hit a little bit of a roadblock. You should be able to tell me right now what value is not in the domain of this graph. Look at that expression for 7a. What value would not be in the domain of the graph? Take a look. There's one x value that we can't get an output for. And y. Analyze it. So we got 1, 2, 3 of us, 4, 6, 5. What do you think our problem area is going to be? Y. Perfect. Looking at it in terms of where the problem is going to be, we know what 1 will work, so that'll be a third and a fourth and so on. So if you just keep plugging together. There's only one time we're going to have an issue, and that's when the denominator equals 0. So you're going to get what's called a vertical asymptote at -2. That means it's sort of like a force field. There's going to be 2 halves of the graph. We would go through and say that there's a vertical asymptote at x is equal to -2. That's a line that goes straight up and down. X equals lines go straight up and down. You could go through and graph this out, and we'll state this now in the interest of finishing this up. Our domain is going to be -infinity up to -2, jump over the -2, and resume going out to positive infinity. Now, there is also one value I'm never going to get is an output value. And this is tough to see. No matter what number I plug in, it's going to get really close to it, but not equal it. What value can I not get as an output? You can't get 0 as an output from this. Does anybody know why? In order to get 0 from a fraction, what does the numerator have to have as a value? 0. What's our numerator always going to be? It's going to be 1 over a billion. Is that really close to 0? Yeah. Is it actually 0? No. So our range would be from -infinity up to 0, jump over the 0, and keep going. You can go through and graph these out to figure out what the graphs themselves would look like. You could go through and do that. Now, if you want the graph for B, that's what it would look like. It would be a quadratic, blah, blah, blah. Now, your homework for tonight is to go through. It's on that sheet. You put a check mark next to the questions you've done, and they go right in order. So, thank you so much. Now, what we're going to have you to do is this. On your homework sheet, it references on there worksheet 1.2. Did I give you worksheet 1.2? Can you do worksheet 1.2? No. Just get the questions that are done from that packet, please. Great job today. Sorry we were so rushed. Make sure your calculators go back in the correct slot. Have a great rest of your day. That's fine. me ask you this. Do you have any free periods during the day today? Would you be able to do it 4? Bring in, okay, not a big deal. Thank you very much. Yep. Yeah, let me just go back to where we had. I need to see if they can come on. All right, so we're talking about B. Because you've got 3 minus 3. Joe, you know why? You know what it was? It's probably because I did it in red.
Yeah, I think that's why.
It might
I
have
was
seemed
thinking
disconnected.
Okay,
Okay?
yeah.
All right.
Another one of the,
Yes, and there's one on, posted in Google Classroom. I forgot to tell you. I think I just slide over, let me see. Yeah, here you go. Yep, we'll see you later. Have a good rest of your day. Are you guys going to win your game today? Who are you playing? All right. Well, good luck.